Welcome to this brief screencast where we're talking about the next big piece of programming, subroutines. Subroutines allow us to really handle complex programs. If we didn't have subroutines, we'd have to write down the code, the task, to do everything. And if we wanted to do a task, let's say calculate an average 7 times in our program, calculate the grade point average for class A and grade point average for class B, and then maybe the average temperature or something, you would have that code copied again and again and again in your program, which is really a pain in the butt to have to keep copying the code again and again. So what a subroutine is basically is a bundling or grouping of the instructions for a particular task, calculate the average or print out a table or something, and then we actually name them so that we can refer to them later on and actually call them when we need to do that task. One of the other beauties of subroutines is you can call a subroutine from inside a subroutine. As you can imagine, this can get a very complicated, this subroutine is calling that subroutine, which might be calling the first one back again. Excuse me, I'm trying to get over this cold. But it can build up a very complex solution without losing picture of, where am I and all this stuff. It allows us to sort of bundle and compartmentalize our problems and be able to build up a very complex solution. One of the reasons we can do this is we can treat subroutines as black boxes. Excuse me. We don't need to know what they do in particular, as in how they actually do it. We just need to know what they can do and how we can call them when we need that particular task done. So there's two things we need to know. One, the purpose, what they do, and two, exactly how do we call them? What is the interface? It's got to be straightforward, it's got to be well defined, it's got to be easy to understand. So I got to be able to know what it is, and it's very particular, as in, computers only do what they're told, so it's got to be very particular. And it must be easy for other users to understand what this particular subroutine is doing and how you would actually call it. So from the outside, it's nice to say, I don't care how this subroutine does its job, I know it's going to do its job. All I need to know is what's its name, if there are any parameters I need to give it, and if there's anything it's going to return to me, like the answer or whatever of the particular task it's solving. Subroutines don't need to have parameters. They can, and they can or cannot. They don't need to have a return type, but they can have a return. So it's going to return something. It might be the answer. So from the outside, I just say, I want this task done. I give it the information it needs. It's going to go do the task, and I can say, task complete. I'm going to go on and continue solving the problem. Very nice, and I don't worry about the innards of the subroutine, how it does its job. It makes my life as solving the problem is much simpler, but I say that problem is solved because the subroutine did what I needed to. Now from the inside, as I'm developing the subroutine or working on the subroutine, I don't need to worry about the outside world and all the complexities out there and all the other things that are going out there. I just need to worry about what I need to do to solve the particular task for this subroutine. I don't have to care who's going to call it, how many times they're going to call it. I don't have to care that the program out there is doing all this work. I just need to know how to do the task that this subroutine is supposed to do. I know what the parameters are that I'm given. I just need to figure out how to make this thing do what it's supposed to do. Very nice to say, I can ignore all that other stuff and just focus on my one task. Again, that simplifies my work, because I can focus on my task, get that done, and then someone else can call my subroutine and know that it will do the right thing. So that makes the two types of black boxes from the outside and inside make solving these problems much simpler. So what are the specifications? I need to specify what this interface or what this subroutine is and what it does. So it's got a semantics, what it does. I need to know what the task is that it does. If I don't know what it does, why would I ever call it? And I need the specific syntax, the syntax of what's its name, what are its parameters, what are the types, what are the return type, and we want to document this so that people can see and know how to use our subroutines. And so we use JavaDoc, which is a program that is a way of documenting or commenting our subroutines. It has a description of what the subroutine does. It has a description of the parameters, if any. So you describe the type of the parameter, the name of the parameter, and then potentially any restrictions on the parameters. Maybe it's a positive number, so you say it's a positive integer. So you say, int n, parameter int n has got to be greater than 0. Description of any return value. So maybe it returns true if something is greater than 7, or false if it's less than 19, whatever. And also a description of any exceptions that may be thrown by the subroutine. And this allows people to look at the description and know, hey, I could use this subroutine to solve my task. So there are two types of Java subroutines. They're static and non-static. Static ones, sort of like public static void main, are associated with the class. And in order to call them, you have to use the class name and then the method name. There can also be static variables associated with the class that can be accessed by these static methods. Non-static methods are associated with an instance of the class, and don't worry about what an instance of the class is. We'll talk about that next chapter. But there's basically this chapter we're going to focus on the static methods that are associated with the class, very much like the public static void main. So how do we define a subroutine? Because we need to define the subroutine, and what does that look like? Well, the subroutine definition is a bunch of modifiers, potentially none, a return type, what the subroutine is going to return, the name of the subroutine, open parentheses, a list of parameters, or parameter list, that are things that you can pass into the subroutine and be used by the subroutine. Potentially that list can be empty, close parentheses, we have an open curly brace, and then the statements that actually implement the subroutine, and then a closed curly brace. Now this is slightly different than the while loops, the for loops, and the if and the switch statement, in that we need to have the curly brace. You cannot write a subroutine with only one statement without the curly braces. That's not legal. So what are some of the modifiers? Well, we've already seen public static for main. There's some other ones out there. The return type is, what's the return type of the subroutine? Well, in the case of a subroutine that doesn't have a return type, you type void, like in main, public static void main. And then the name, main. And then the parameter list is information that can be passed into the subroutine that allows you to change what the task, not change what the task does, but maybe change the data being operated on by the task. The parameter list is a type parameter name pair. So we always know what type of the parameter is, and then we have a name for the parameter so we can refer to it in the subroutine. And if we have more than one, they're comma separated. So here's an example of a subroutine definition. We got public static void play game, open paren, close paren, curly brace, and then the code for playing the game. So the modifiers are public static, return type is void, the name is play game, and the parameter list is empty. Next one, int get next n, parameter, open paren, int n, close paren, and then the stuff to do it. In this case, there are no modifiers. We don't have a public, we don't have a static, we don't have a private. We just have the return type int. The name is get next n, and it has one parameter in the list, and it's an int n. So inside of the subroutine, we can refer to n, and that's some information being passed in. We'll talk about that later, next lecture, next screencast. Next one, static boolean less than double x, comma double y. So the modifier is static. We don't have a public or a private, so it's just static. Boolean. So that's the return type. It's going to return a Boolean value, either true or false. The name is less than, sort of implies that if x is less than y, we should probably return true. But we don't have enough description. I don't know what the stuff does, but that, just the description or the name implies that if x is less than y, this subroutine would return true. We have two parameters. One is double x, and the second one is a double y. And then let's talk about specifically those access specifiers. This is the public, the private, the not having any. And there's another one that we'll not talk about right now. Basically, it's protected. The author suggests that you could do either. I suggest that you choose either public or private. If it's public, this subroutine is going to be accessible by anybody. So anybody can use this subroutine outside of the class, outside of the package. Anybody could use it. If it's private, it's only usable by the same class. So people outside of this class cannot use that subroutine. So you should decide whether or not you want everybody to be able to use this subroutine or only have it be local to the class or only the class. Sort of like a helper subroutine that does a little task that doesn't make any sense that other people would want to do that kind of task. If you've broken the problem down enough, there's some tasks that you would do to help solve your problem, but they're not really meaningful to outside people. So those would be private subroutines. I suggest you choose either public or private for this course because it makes you think about the sort of the purpose of, do I want other people to use this subroutine, or is it really sort of an internal bookkeeping thing? And if you leave it with none, then you've got the issue of, did you really intend it to be usable by all, or did you not really want it to be usable by all? So just make that decision of whether it should be public or private. So how do we call subroutines? Basically, for static subroutines, inside of that same class, so class project, you just say subroutine name and then the open paren, you supply the parameters, and then close paren and semicolon. If you're calling that subroutine from a different class, you need to supply the class name dot subroutine name parameters. So it's very similar to system exit is a static subroutine on the system class that it will tell Java to stop. If you want to call that outside of the system class, which is everywhere you're going to be working, you have to say system.exit. Now, if we were inside the system class working on something, we could just use the name exit. So that's the difference. So if you're calling another class's subroutine, you got to have the class name. And these are static subroutines, because that's all we're talking about for this chapter. So you class names, the name of the subroutine, and then the parameters, and they must have the right type, and they must be in the right order as the parameter list in the definition. So here's an example. We have our class guessing game. It's got the public static void main where we start the program. We have the Boolean play again, so the init is initialized to false. So we do the do loop, and then we call play game, which is here down at the bottom. We have the public static void play game, and that's where we put the code that does the task of playing the number guess game. And then we print out, after that runs, we print out, would you like to play again? We go get the Boolean value from the user, and then we hit the while from the do while. If it was true, we go back up and we play another game by calling the play game subroutine, and we keep going until the user says they don't want to play again, and then we'll drop out and we're done. So we can call the play game multiple times by just calling the subroutine name and providing any of the parameters. In this case, there are no parameters. So we talked about subroutines. I briefly mentioned member variables. Basically, member variables is another concept of variables. We've already talked about local variables, which are declared inside subroutines, and they're only available inside that subroutine. They're not accessible outside the subroutine. But what if we wanted a variable that's accessible to more than one subroutine? we'd have to somehow, we can't declare it in one of the subroutines because it's not available to the other ones. So how do we do that? So we actually declare them outside of the subroutines but inside the class. If, again, these member variables are variables that are visible to everything in the class, they can be static, which means they're associated with the class, or they're non-static, and again, we're going to talk about that next chapter. They also have an access specifier, so we could make them public, which makes them visible to everybody everybody can access them, or we can make them private, so they're only available to this class. So static member variables are shared by all static subroutines. So that means if I need to have some sort of thing like how many games we've played, and we have a bunch of subroutines, I think that's my next example. How many games were played, how many games were won, we have the same main and we have the play game, very similar to the previous one. But in this case, the main keeps track of how many games have played and how many games are won by incrementing games played, the variable, after play game. And maybe play game will remember whether or not you win or lose. So play game can update the number of games won by just saying if you won, increment it. If you didn't win, then we don't increment games won. But the main loop keeps track of how many games were played. So each time it calls play game, it increments the number of games played. So, and then at the end, the main can access both games played and games won, so that it can print out the statistics of you played 7 games and only won 1. Sorry. So this static member variable is accessible by both the all static subroutines in this class because it's private. It's not accessible to people outside of this class. So if I had another class, cannot access the private static games played or games won in guessing game 2, but I can access it inside this class. And that's all I have to say about subroutines. So they're a powerful, subroutines and member variables, powerful way of grouping our code into, or bundling our code into tasks that can be called again and again and again. It's a great way of organizing our code such that we reduce the complexity and make it much simpler to solve complex problems by deferring the work to the subroutines. And again, while we're building up solutions, we just say, oh, I don't have to worry about how that subroutine does its job. I'm just going to call that subroutine. And when we're building the subroutine, I don't have to worry about who's going to call me, what they're going to do, why are they calling me. I just solve my task, and so it makes programming a lot easier. Thank you very much, and I apologize for my voice.